Hey everyone, and thank you very much for joining AstrumDrive podcast. My name is Ivailo Vasilev, and this morning we're joined by Nelson. He's the head of our physics department. Today we're going to do a recording for one of our stand-ups. We're in the middle of sprint 3. So Nelson, please go ahead and just give us a brief idea what we're currently doing right now.
Hello, everyone. Thank you for joining. Sure, Pailo. This basically what we're doing at this point is reviewing a few articles to start. These articles are very interesting ones that are starting to appear and around, let's say, 2017. And these articles consider different matter content. Different matter content in the sense that the original works made by Alcubierre and Natarius later, these works just basically consider configurations or like dust, and the in the best scenario just a perfect fluid. And now these articles, they publish nice results where basically they put more general function in Alcubierre's metric, and they started working on Einstein's equations, which is something very basic to do. We are able to do that with our mathematical notebook at this time. And then is interesting is that they found a lot of cases. So they divided and made a large classification, very nice done, where different cases appear. Of course, not all cases are physical, and then you have to figure it out what's going on there. And then we're looking into that. We're looking into that because we think that we can find we can put some specific features there that would might change the physics. In fact, the physics that they see. And anyway, one of the things that these guys don't do is they don't solve Einstein's equations. They just obtain the equations, which is a lot of work anyway. But we're aiming into to solve the equations, at least in the most interesting cases, and find some solutions that we can interpret it physically uh, with specific plots and so on. You see, that's one thing. The other thing is looking into more or less the end finally of the Notarius paper. The Notarius paper is very important for us because it's what we're using to understand how this warp drives works, at least in the sense of Notarius and Alcubierre. And basically, the last ticket that we finished is related to proving uh, a relation that Natarius uses in his paper uh, that is related to the strong energy conditions. This is basically just a projection on the energy momentum tensor and the metrics on the surface. And this is something that is done by thinking in this foliation of the space-time. So you can find general expressions. These general expressions then are in terms of the extrinsic curvature, but you can also find that these are connected with simply with Einstein's equations. And at the end, we wanted to just find out how to prove this, which we did by hand anyway, and then to implement this. Basically, this is already implemented in mathematical notebooks, but there are a few things that you need to change and to add, and find basically the basic problem that we have. Is we found already that if you have this metric is and you have dust or a perfect fluid, you obtain that the only solutions that you got is negative density energy solutions, which is basically saying that you have a letter that we use rho, which is the density energy, is equal to minus something that is always positive. So there is no escape from that. The only way to change that is that you change how you are projecting, in a sense, which is equivalent to say that you uses or you see everything from a different server, or we start working out to see if there's something that we can look into Einstein's equations, which is now connecting with the the previous part that I said at the beginning. So basically, that's what we're doing now. I started today, in fact, as looking into what is called set expansion of Natario's work. And that's quite interesting because with zero expansion, Alcubierre's work changes a bit, and you got to write everything in a like in a spherical symmetry way, which is quite nice for us. It's very interesting. This one. This is what is going to connect with the previous thing that we have done in the last and the previous two one sprints. Uh, and this is very nice. Still working. I started today working on this, but it's quite interesting because it gives you a more physical sense of what's going on here and how do you select directions and what is the role that each of the specific features that are in the matrix play into the warp dry condition. Basically, we want to understand the warp dry condition, and because it has so many uh, ways of looking at it, and so many different characteristics and so many implications that once you can get more experience and manage everything, is then you can even modify or create new things. There are some works made already in these directions, and we are reviewing all this.
Thank you, Nelson. It's quite exciting the direction in which we go because we start seeing the implications from the physical world for the work we do on the warp drive. So we understand better how the warp drive is something we can actually create, which is very, very exciting and interesting. Okay, excellent. So, is there anything else you want to add to the stand-up?
Well, not really. Please ask any questions you want. Support us. Make questions. Make questions, please. And there is a box. Just write down and that you can just write comments and everything else.
Yes, please do. Please do. Thank you very much, Nelson, and thank you to everyone who is listening this podcast. If you like what we do, please support us on Patreon, like and share the video. And with that, let me wish to all of you to have a very nice and successful day.